I'm using scikit-learn's Gaussianprocessor to build a model. I'm choosing a PairwiseKernel to see how data points relate to each other. This is a special tool that lets me study relationships between data in a specific way. I'm testing your knowledge about the PairwiseKernel in scikit-learn. We'll look at several statements and you tell me which ones are correct. This checks your understanding of how this tool works. PairwiseKernel is the star of this quiz. It's a function in scikit-learn that makes a table, a kernel matrix, showing how similar each pair of data points is. This similarity is measured using a base kernel function, which we select. This statement accurately describes the core job of PairwiseKernel. It takes a BASEKERNEL, a function that measures similarity, applies it to each pair of data points, and creates a kernel matrix. The matrix shows how much each data point resembles every other data point. The PairwiseKernel uses a BASEKERNEL. That's a function that decides how to measure similarity between data points. It could be a radial basis function kernel, RBF, a linear kernel, or another. The choice depends on the type of data and what kind of relationship I expect to find. The result of all the pairwise comparisons is called the kernel matrix. It's a table where each cell, row, column, shows the similarity between the corresponding pair of data points based on the base kernel. For example, a high value indicates the data points are very similar, and a low value shows they're dissimilar. This matrix then informs the Gaussianprocessor about the structure of my data. This statement is incorrect. I've made this statement intentionally to test your understanding. It wrongly limits what kinds of BASEKERNELs you can use with PairwiseKernel. The reality is that PairwiseKernel is quite flexible and is not limited to just vector-based data. This is a correct statement. The awesome thing about PairwiseKernel is that I can use more than one BASEKernel at once. This lets me find more complicated relationships in my data, leading to a more powerful model. This is false. While using a PairwiseKernel often helps, it doesn't magically improve things every time. The results will depend on your specific data and the BASEKernels chosen. This title introduces the core topic. We're diving into scikit-learn's PairwiseKernel, a powerful tool for building machine learning models. It's going to be a deep dive, so buckle up. This is the data you feed into the PairwiseKernel. Think of it as your ingredients for a recipe. It could be anything from images to sensor readings. The important part is that the PairwiseKernel will work with it to determine similarities between data points. The base kernel is like the cooking method. You choose a base kernel, or multiple kernels, to define how you'll measure the similarity between data points. Examples include radial basis function, RBF, kernels which measure distance, or linear kernels, which measure correlation between points. The PairwiseKernel is versatile. You get to choose the cooking method. This is where the magic happens. The PairwiseKernel takes your input data and chosen base kernels and calculates a pairwise similarity for every data point in your set. It's like comparing every ingredient to every other ingredient in your recipe to find common flavors or textures. The output of the pairwise computation is a kernel matrix. Imagine a table where each cell shows how similar two ingredients are. This matrix is a summary of all pairwise relationships in your dataset and feeds into the next step. The kernel matrix, K, forms the input of the Gaussian-process regression model. This model uses the relationships captured in the matrix to make predictions. It's like using the flavor relationships in the recipe to predict the final dish's taste. Finally, after the Gaussian-process regression model does its work on the kernel matrix, I get predictions. It's like getting the final dish after using all the pairwise relationships. similarities of the ingredients to predict the overall flavor and texture. I'll explain what a pairwise kernel is in scikit-learn. It's a tool we use to create a relationship map between data points. Think of it like making a connection chart showing how similar different points are to each other. We'll see how it uses base kernels to build this map. Let's dive in. This is the data you feed into the pairwise kernel. It could be anything that your base kernel can handle: numbers, vectors, or other data types. The pairwise kernel will then compare every single data point to every other data point. This is where the magic happens. I take the base kernel, or kernels, it can handle more than one, and apply it to every possible pair of data points. This means I calculate the similarity between data point 1 and 2, data point 1 and 3, and so on, until I have compared every pair. I'm comparing all the points. These are the functions I use to measure similarity. You can select several different options like the radial basis function kernel, RBF, or even combine multiple kernels to handle diverse aspects of your data. Think of these as the building blocks of your similarity calculations. The result of all that pairwise computation is a table, matrix, showing all the pairwise similarities. Each entry in this matrix tells you how similar 2 points are based on your base kernels. It provides a compact representation of the overall relationships within your data. This will be a crucial input for your Gaussian process regression model. The final output is the kernel matrix. It's a structured way to represent all the pairwise similarities I've calculated. This matrix is the key to understanding the relationships between your data points, which my Gaussian process regression model then uses to make predictions. Now, that's powerful. That's correct. I can handle multiple base kernels. This gives you tons of flexibility to model complex relationships between your data points. The more base kernels, the more ways I can consider similarities. Cool, right? Absolutely. That's my main job, creating this kernel matrix. Each number in this matrix represents how similar a pair of data points are. The method for measuring this similarity is determined by the base kernels you choose. This question tests your knowledge of scikit-learn's pairwise kernel, a function used in Gaussian process regression. I'll guide you through the options. I'm going to help you understand exactly what a pairwise kernel does. Get ready. This sets the stage for the multiple choice question. It's all about understanding how pairwise kernel works. I will walk you through the various options, identifying which ones are true and which are false. This statement is incorrect. I found that pairwise kernel is not limited to vector-based kernels only. It's more versatile than that. This is correct. You can use multiple kernels together with a pairwise kernel to get a more sophisticated model. This is a powerful feature. Think of it as having multiple tools in your toolbox. This statement is false. While a pairwise kernel can improve performance by capturing complex relationships, it's not a guaranteed improvement. The best kernel really depends on your specific data. This statement is absolutely correct. That's the main job of pairwise kernel, to calculate a similarity score between all pairs of data points. I find this is a key concept to grasp. This is the type of regression model where the pairwise kernel is used. It's a powerful method for modeling relationships in your data. This is the core focus of the problem. I found that pairwise kernel is a function in scikit-learn that computes a kernel matrix based on a chosen kernel, or kernels. This is the output produced by the pairwise kernel. Think of it as a table where each cell represents how similar 2 data points are. Each entry describes the relationship between 2 data points. This question asks you to identify correct statements about the pairwise kernel, a function in scikit-learn's Gaussian process regressor. I will guide you through each statement to determine whether it's true or false. It's a multiple-choice question testing your understanding of how pairwise kernel works within a Gaussian process regression model. This is absolutely true. Pairwise kernel is really cool because it's not limited to just one type of kernel. You can combine different kernels, such as radial basis function, RBF, and linear kernels, to create a more flexible and powerful model that can capture more complex relationships within the data. Think of it like mixing different ingredients in a recipe to make a better dish. This statement is also correct. At its heart, pairwise kernel calculates a matrix. Each cell in this matrix shows how similar 2 data points are, as determined by the kernel you selected. so it's a powerful way to systematically compare every pair of data points based on the chosen similarity metric. This is false. Although PairwiseKernel works well with vector-based kernels, like the common RBF kernel, it's not restricted to them. It's more versatile than that. This statement is false. While using PairwiseKernel can often help, it doesn't automatically mean your model will always perform better. The improvement depends on factors like the dataset and the specific kernels used. Sometimes, a simpler single kernel can be more effective. I see these as the individual data points you feed into the PairwiseKernel. Think of them as the raw ingredients for building a relationship map between each point. These are the functions that determine how you measure similarity between pairs of data points. I can use one or many. For example, a radial basis function, RBF, kernel measures similarity based on distance, while others may be based on different mathematical functions. The choice depends on the data and what I'm trying to model. This is where the magic happens. I take each pair of input data points and apply the chosen base kernel function. The result shows how similar each pair is, resulting in a numeric value showing how related the pair is. Think of this as creating a similarity score for each pair of points. This is the final output of the PairwiseKernel calculation. A table, matrix, where each entry shows the similarity score, from the calculation step, between two data points. The entire table shows all pairwise relationships. It's like a complete relationship map that I'll use next. This is a statistical model that uses the kernel matrix to build a prediction model. I use the kernel matrix from the PairwiseKernel as an input to the Gaussianprocess regression model for prediction. This is the final result, the model's predictions based on the relationships identified by the PairwiseKernel. Think of this as using the relationship map to answer questions about the data, such as predicting values for unseen data points. This is the core question that you are trying to answer. The question is about understanding how the PairwiseKernel works and its capabilities. This statement is false. I can use a PairwiseKernel with various kernels, not just those that handle vectors. This statement is true. I can actually combine multiple kernel functions to capture more complex relationships between my data points. That gives me awesome flexibility. This statement is false. While using a PairwiseKernel can often improve performance, there's no guarantee. It depends entirely on the data and the chosen kernels. This statement is true. The main job of a PairwiseKernel is to build this relationship map, kernel matrix. Each entry shows how similar a pair of data points is. This is the title of this problem set, which is a quiz about PairwiseKernel, which is a function in the scikit-learn library. This is a type of machine learning model that I'll use alongside the PairwiseKernel. It's designed to handle uncertainty and make predictions based on the patterns found in the kernel matrix. I see this as the overall topic. We're diving into how a special type of kernel, called the PairwiseKernel, works within the Gaussianprocess regression model in scikit-learn. It's a technique to model relationships between data points in a more sophisticated way. This is the core question we need to answer. We'll analyze each statement to determine if it accurately describes how the PairwiseKernel operates. This statement is false. I found that the PairwiseKernel isn't limited to just vector data. It can handle various kernel types. This is true. The PairwiseKernel offers the flexibility to use multiple base kernels simultaneously, allowing us to capture more complex relationships in the data. This statement is false. While it often helps, there is no guarantee. The improvement in performance depends on data and the chosen kernels. This is true. That's the main job of the PairwiseKernel. It calculates a matrix showing how similar each data point is to every other data point, using the chosen kernel to define similarity. This helps visualize the process. It's like a machine with inputs, a processing unit, PairwiseKernel, and an output. This is the data we feed into the machine. This could be anything the chosen kernel can handle. These are the formulas that define how we measure similarity between data points. The PairwiseKernel takes one or more of these. This is the core process. The PairwiseKernel takes each pair of data points and applies the base kernels to see how similar they are. This is the output, a table showing all pairwise similarities. The kernel matrix is used here for predictions. It's the central piece linking the data to the predictions. Finally, we get the results, the predictions from the model using the pairwise similarities.